So in previous lecture, we understood the concept of moving average. We talked about the purpose. Why do we use moving average? Then we also did one short example that how do we do it? Why do we do it? Now, let's use moving average method and find out the trend and seasonal variation. So now we are going to calculate that, make that forecast using the time series method. And while doing calculating the time series method, we need to use the moving average approach. Okay. So what happens in time series? You are given some data. So for example, there are some periods, year 1, year 2, year 3, and we have divided them into quarters. So quarter 1, quarter 2, quarter 3, quarter 4, then year 2, year 2, 4 quarters, year 3, 4 quarters. And then probably the question is, or the question could be to find out the sales for year 4, quarter 1, or maybe year 4, quarter 2. So this could be your task, that based on this data, find out the sales forecast for the first quarter of year 4, or maybe the second quarter of year 4, or maybe the third quarter of year 4. So what data? Historical data. Like we said that in time series method, we use historical data. And then the historical data, we take averages, but we don't take simple averages. We take moving averages. So these are the sales which are given to us. So if we see that the sales are 18, 60, 90, 102, then 30, 72, 99, 120, and then so on. So we see that the sales are increasing. So they are lowest in quarter 1 and highest in quarter 4 because of some seasonal impacts. We said that there are seasonal variations. But overall, if I see that the trend, so if I see that quarter 1 in year 1 is 18, and quarter 1 in year 2 is 30, and then quarter 1 in year 3 is 36. So the sales, they keep on increasing. So it goes to quarter 4 maximum, but then it comes down. But when it comes down, it still is above this one. So if I see it goes like this, okay? So let me just kind of just making it for myself. So it's not part of the lecture, but I just want to see that how this data looks like. So this is quarter 1, quarter 2, quarter 3, quarter 4. It drops down. But when it drops down, it does not come to this point. This is 18. It comes down to 30. Then it goes up, it goes up, then it goes down. But this is 18, this is 30, this is 36. So you can see that there is some kind of seasonal variation. But overall, the trend actually is going up, because here the quarter 2 is 60, here the quarter 2 is 72, here the quarter 2 is 90. So I can see trend going up. Anyways, these are the sales. Now, they ask you to calculate 4-period moving average. And in the previous session, we discussed that if you have an odd number moving average, you need to do one step. But if you have an even number of periods like 4, 6, 8, so 3, 5, if it is 3 quarters moving average or 5 quarters moving average, life will be easy. If it is 4-quarter moving average or 6-quarter moving average, like even number, then you have to perform 2 steps. This is exactly what we learned in the previous one. The reason is that it does not come in front of the number. What does that mean? Let me show it again. Although I've explained it in the previous session, let me do it again. I'll show you again. So we say that we have to calculate 4-period moving average. So 1, 2, 3, 4. We add these 4 years or 4 quarters. And we find out, we make a total, divide it with 4, and answer is 67.50. But now the problem is that this 67.50 is actually the midpoint. It is in the middle. So the middle is not actually in front of any particular, because it is 4-period, 1, 2, 3, 4. Middle is somewhere here. That's why I put these dotted lines. So the middle comes somewhere between the second and the third quarter. Okay, if it had been quarter 1, quarter 2, and quarter 3, the midpoint will be in front of quarter 2. the midpoint. But if it is 4 quarters, the midpoint is actually 2.5 quarters. It is between 2 and 3. So this is the 4 period, 4 quarters moving average 67.50, which comes in the middle of these 2 points, 60 and 90, between second and third quarter. Then you calculate the next one. And in order to calculate the next one, what you need to do, you have to ignore this one and add this one. So eliminate one previous one and add one new one. So what you need to do now, take another period, which is like quarter number, this from this 60, 90, 102, and 30. Four quarters. So you ignored the first one and you added this one. Okay. Now you take average is 70.50, but again, it appears somewhere between the second and the third here in this line. Then you repeat the process again, ignore this 60 now, and 90, 102, 30, and 72, and take the next 4. Ignore one previous one, which was 60, and then you take 90 plus 102 plus 30 plus 72, add them up all, divide by 4, answer comes 73.50, and again, it is somewhere in the middle. So what is happening, that you are finding the averages, but these averages do not lie in front of any single period. It's not quarter 2, it's not quarter 3, it's not quarter 4. It is somewhere in the middle. And you will find out all of them in the same way, but all of them, they appear somewhere in the middle. So now what you need to do, you need to do center of them. We call it MA of MA. You can call it MA of MA, which means moving average of moving average, or you can call it centered moving average. And that will be your trend. That will be your trend, okay? So what we need to do now, we need to take these two numbers, we add them up, and we divide by 2. We take two numbers, 2 years, and divide by 2. So it comes 69. Now, if you see that 69 is actually appearing exactly in front of quarter 3. So the purpose of doing this step number 3, the purpose of doing this step number 2, step number 2 here, so that you can take the average of these two numbers and put it in the middle, and the middle point is this, and this is exactly in front of quarter number 3. Then the same process you repeat for these two numbers. Take average, divide by 2, and the number which comes in the middle is actually exactly in front of quarter number 4, and so on. So the purpose here is that we are doing center of this thing. So in the second step, you will take like this and continue. Now you have got your data. Of course, you don't have any number for quarter 1 in year 1 and quarter 2 in year 2. And similarly, you also do not have any number for quarter 3 in year 3 or quarter 4. These 4 cells are, how to say, empty because there are no data available. Now, I've got these numbers now, 69, 72, 74, 78, 81. You see now you've got the trend. Before, what was happening? Before, your sales were like this, 18, 60, 90, 102, it went up. But then suddenly it became to 30, it went down. Then again, it started going up, it started coming down like this, okay? So this is year 1, this is year 2, this is year 3 quarter, like this. Now, but if you see here, there is no change. It is continuously increasing. There is no ups and downs. So what you have done, you have calculated your trend line. Remember in the previous session, I told you that actual data is like this, and the trend is the line which goes in front, in the middle, and it is increasing. So we can see that the trend is increasing, like 18 in quarter. Trend is increasing. Even if you see this, your period, which is quarter number 4, 102, 120, 135. So every time quarter 4 is increasing, every time quarter 3 is increasing. So overall it is increasing. But when you saw this data, it went up and down, and you wanted a straight line. And that straight line we called trend line. And that trend line is here. 69, 72, 74, 78. So it is increasing. This is what is the trend. Now, The problem here arises that sometimes, so this is average, moving average, and this is trend. But problem is that it is different from the actual data. If you see actual data is 90 and here it is 69. So your trend is actually below the actual number. If you see this one, 30 is the actual number, but trend is more. Why it is more? So what it looks like that these are the actual data for quarter 1, 2, 3, and this is the trend line. So if I take this point, at this point, the trend is below, the actual value is above, which probably is this one. Trend is below and the actual value is above. But when I come to this point, the trend is above and the actual value is low. So maybe this one, trend is above, but the actual value is low. And my trend is actually an average which is passing through from the middle. So there are some values up, some values down. Why they are up and down? Because of the seasonal variations, which we discussed in the previous session, because they go up and go down because of seasons. This is peak season, you get maximum sales. This is off season, you get lowest sales. So because of these seasonal effect, what will happen that your trend line, which is the average, and the actual data, they are not same. There is some difference. How much is that difference? So if I ask you, for example, let's make it again. I've got data until here, okay? So I can forecast it, I can extend it, I can extrapolate it. So how much will be the sales here? This will be my average. So actual will be how much? Maybe if it is off season, it is like this, it is going up. So you will say trend value is this, but actual value will be that. This is how you can predict. This is how you can, do forecasting based on the seasonal impact, that if the trend value is here, where is the actual value? Maybe it is above, maybe it is below. So how do we calculate that? We say that what is the relationship between the trend and the actual value? So what I'm going to do, I am going to divide these two numbers. So if I say, okay, if actual is 90 and the trend is 69, so 90 divided by 69, what is the factor? Factor is 1.3. 1.3, what does it tell me? 1.3, it says that in quarter number three, the actual value is 1.3 times more than the average number. So whatever is the average, multiply it with 1.3, you will get the actual value. This is what it says you. 1.3 means 1.3 times. So 69 into 1.3, you get 90. So the actual sales would be 1.3 times more, which means 30% more than the average sales in quarter number 3. In quarter number 4, if you pay attention, it becomes 1.417 because we divided 102 with 72. But in next period, in quarter number 1, sales are just 30 and trend is 74. So it means that in quarter number 1 of every year, whatever is your average, whatever will be your trend or average, the actual sales will be 40% multiplied by 0.4. Multiplied by 0.4 means actual sales will be 40% of this number. Okay, so quarter 1 is below the average, quarter 2 is above the average, 3 is above, 4 is above. So this is how you will calculate. I'll do it for all of these values like this. So what do I have now? I've got, and these numbers I call variations. These numbers I call variations, seasonal variations. So we calculated the value of seasonal variations. So this is my trend multiplied by seasonal variations. You actually here, you will get 90. If you do like this, you will get 102. If you multiply these two numbers, you will get 30. So I just made a relationship between trend and this one using these seasonal variations, okay? Now, I've got variation. So I know that one thing is for sure, that if I tell you that trend line, let's suppose that the trend line, so when I will extend this trend line like this, if I say that my trend here, let's suppose that trend here in quarter number 3 is 100, let's suppose. This is average. How much is this one? Okay, this one I have it. Let's suppose it in year 4. Year 4, quarter 1, let's suppose. I say the trend here is 100. How much will be the actual sales? Will it be 100? You say no, because I know that in quarter one, the trend is 0.402. Variation is 0.402. So it means 100 multiplied by 0.402, this number should be close to 40. This number should be close to 40, because trend I can predict, trend I have here, I can expect it like this. But then whether the actual number will be above or below, that I will multiply with my seasonal variation. So if average is 100, but in quarter 3, in quarter 1, usually the sales are only 40% of the trend. They are below the trend. They are below the average because it is off peak season. It is not peak season. It is off season. So you multiply 100 with 4.402, it is 40.2 or something. You can do like this. Okay. But here another problem arises. The second problem which comes your way now is that you've got 0.402 for quarter 1, but then you have another quarter 1, which is 0.409. So you've got 2 seasonal variations for first quarter. Similarly, for quarter 3, you have got this variation, and for quarter 3, you have got this variation. So you've got 2 variations for quarter 3 as well. And similarly, for quarter 4, you also have got 3 variations, 2 variations for quarter 4 as well. So which one should I take? I know that I have to multiply with 0.40, which I did before, but then I've got 0.409 as well. So which one I should take? Because there are more, the data has 2 sets of seasonal variations. So I put them like this. I say quarter 1, 2, 3, 4. Year 1, there was no data in quarter 1 and quarter 2. It was empty. Quarter 1, quarter 2 was empty. And year 3, quarter 3 and quarter 4 is empty. Okay. So if I put data like this, it comes like this. In year 1, no data, no variation for quarter 1, 2 is available. But in year 2, I've got all 4 of them. And in year 4, in year 3, I've got quarter 1, quarter 2, but 3 and 4 quarter are missing. Anyways, I make a total and I make an average. So instead of using 0.402, this is seasonal variation from 1 year. This is seasonal variation from second year. So then I got my average variation, average seasonal variation. So these all are seasonal variations. Now we calculate average seasonal variation. Again, you just add them up, divide with 2. Add them up, divide with 2. And when you make a total of them, it gives you a total of 4. And you say, okay, if the total comes out to be 4, that's okay. It's correct. Okay, so these are your seasonal variations. So now when you round them up, you say, I've got seasonal variation. Quarter 1 sales will be 40% of the trend. Quarter 2 sales will be 90% of the trend. Quarter 3 sales will be 1.3 times of the trend, and here 1.4 times of the trend. And trend we can calculate very easily. Now, trend has increased from 69 to 91 over period. Now, how do we, I said trend we can calculate. How can we calculate the trend? See here. Where is my trend? This is my trend. It increased from 69 because it is continuously increasing. 69, 72, 74, 78, 81, 84, and so on. Okay. So it started from 69 and it went up to 91.88. So this is the total change in the trend. And that is something like 22 or something, 21 point or 22 point something. This is a change. So 91 minus 69 is 22. In how many quarters? In how many quarters this change has occurred? My trend has increased from 69 to 91. Suppose it is 22. but it did not increase in one quarter. It increased in 1, 2, 3, 4, 5, 6, and 7. Okay, don't count these values like this. Don't count the values that, okay, it is 1, 2, 3, 4, 5, 6, 7, 8. These are 8 numbers, but both are inclusive. So you have to consider that there are 7 quarters because both are inclusive. So -1. So it is actually the change which has occurred over 7 quarters. If you 1, 2, 3, 4, 5, 6, 7, 8, when both sides are there, you have to -1. If you don't understand, make it like this. This is 1 quarter, this is 2nd, 3rd, 4th, 5th, 6th, and 7th. So I can say that my trend has overall increased by 22 points or $22 or $22,000, whatever, over a period of 7 quarters. So it means that on average, I'm increasing per quarter, I'm increasing by 3. So per quarter, I'm increasing by 3. So if I'm increasing per quarter by 3, so it means that here it should be 94.88. And here it should be 97.88. Trend I can calculate. Okay. So, and then moving on, I can just add 3 and I can calculate the trend. So this is, I come back to this thing where I left it. So you can say that 7 quarters, it's approximately 3. It's approximately 3. So if I ask you that what is this forecast year, step 4, forecast year 4 sales, how much are the sales in year 4? So quarter 1, quarter 2, quarter 3, quarter 4. So in quarter 1, first you put the trend values and then you put the seasonal variations and you multiply them and you get the sales. So how much are the trend values? The trend values are, it's very interesting, please pay attention here. The trend value is 91.88 plus 3 times 3. Why do I do 3 times 3? Remember, when I had my quarter 3, year 3, I had data for quarter 1, quarter 2, quarter 3, quarter 4, and this is year 4, quarter 1. I had data here 91. I had data something like 88 or something here was, I'm not sure. But I did not have data for these 2 quarters. Let me go back and show you. Let me see the exact numbers. So it was 88 and 91. I'm removing these fractions, 88 and 91 in quarter 1 and quarter 2. So what did I have the data there? I had data here, 88, and here I had 91 in quarter 1 and quarter 2. I did not have anything for quarter 3, quarter 4. And they asked me to put data here in quarter 1. So first I need to add 3 here. So making it 94 and then making it 97 and then making it 100. Okay. So it means that if I take this number, I have to add 3, then 3, and then 3 so that I can come to quarter 1. So when I have to come to quarter 1, I have to, because I'm taking the number from 91, which is for quarter 2. Quarter 3 is missing, quarter 4 is missing. So there was an increase. So an increase of 3 happened here, an increase of 3 happened here, and an increase of 3 happened here. So that's why when I calculate my quarter 1 calculation, I say 91.88 plus 3 times 3, which means 91 plus 9, which makes you 100 or something. So this is 101. And then if you remember the average seasonal variation, but when you go to this point now, in quarter 2, you already are 100. You just have to add 1, 3. You don't have to multiply 3 by 3 here. Here you will only say that, okay, if I get 101 here, from 101, I'm just moving 1 quarter forward. So I just have to add 3. When you go to next quarter here, 1 quarter forward, you will add only 3. only one time I have to move this thing because these two columns were blank. So I have to add 3 here, 3 here, and 3 here. Okay. So I put these numbers here, 101 plus 3. So the trend comes out to be 104. Here it will be 107 and 110. And then you multiply them with the seasonal variations, average seasonal variations, which we just did, 0.4, 0.9, 1.3, 1.4. And your forecast sales will be like this. This is your quarter one sales for year number 4. And if you see that, again, it is going up like this from quarter 1, 2, 3, 4, and then it goes down. So this is very much in line what was happening in past. So you have predicted these sales for each quarter in the year 4 based on the data of past 3 years using the moving averages and multiplying the moving averages, the trend values, with the seasonal variations, because you said that there are some variations and we cannot ignore them. Okay. So this is all with this method. And by the way, because I multiplied my trend line with the seasonal variation to calculate this y. So the formula here is y is equal to T times S. So this is called multiplicative model. So if you are using the additive model, then you don't have to multiply, then you have to add trend and seasonal variations. We are using multiple trend line model, so we just need to multiply them. And this is basically which is mostly used for exam purposes. Okay, multiplicative model of time series analysis. That is all with this thing. We will do some more questions when we do the practice kit, but as far as explanation is concerned, we are done with that time series method.